Hi everyone, so let's do an exponential decay example today. Alright, so it says the half-life of a radioactive substance is the time it takes for half of the atoms of the substance to disintegrate. The half-life of carbon-14 is 5,730 years. Determine the value of K in the equation of decay for carbon-14. Alright, so we are dealing with an exponential function. Alright, an exponential function for decay, it takes on y equals ae to the power of negative k times t. So this was an exponential decay function. Now we've got, let's see, y is half-life first off, dealing with an exponential decay function. Alright, so when you see half-life, just think exponential decay. Right, because it's, it's half of what it's going to be. Right? Don't necessarily say it's the rate of decay, right? You're trying to find that in this particular example, okay? Because it says determine the value of K and the equation of decay for carbon-14. And they also explicitly tell you that you are looking for an equation of decay. Okay, so half-life, well, you know that your result is going to be half of A, all right? Because we said that A is the initial value when you've got an exponential decay function. Well, E is a constant. K is the constant rate of decay here. Wow, okay, that handwriting, I do not, so you already may know, I do not have the best. Alright, decay. And then we've got what? T is time in years. Alright, so this is what we talked about last time about exponential decay. If you saw the video on exponential decay and exponential growth about what those functions are, we talked about that these A, K, and T each talked about that. So that was just a refresher. Okay, so result is equal to half of our initial value, and in this case, half times A. We're going to let that be the function, okay? And then E, and then K, and then our T. K is our unknown here, which is what we're trying to find. T is the time in years, and they tell you that it's the half-life happens at 5,730 years. So let's go ahead and put these into our equation. So we get half A, the result, okay, our half-life, is equal to A, E to the power of negative K, and then times 5,730. All right, so because we just let A be A, that's what we're doing. A is equal to A. So we're not changing much there. We just need to find K and what the equation is. Alright, so half A equals AE to the power of negative K times 5,730. And let's go ahead and work this out. So, you can do horizontal cancellation. The A's would go away. So you're left with a half is equal to E to the negative K times 5,730. Right? Basically, what happens is you can, here, I guess, let me show you what happens. You have an A on both sides. You can divide by A, and you get a half is equal to E to the negative K times 5,730. Okay, you can do that because there's A on both sides, and you can also do horizontal cross cancellation because you have an A on both sides, they go away. Of course, this is only valid for multiplication and division. Okay, anyways, okay, so we have half equals E to the negative K times 5,730, and then now we have an exponent of E on one side, and then we have a constant on the other, so I can go ahead and take the natural log of both sides. So I have natural log of, let's see, E to the negative, I can multiply 5,730 to K, so it's negative 5,730K. Okay, and then I can take the power by the power rule. I can take the power out of inside of my natural log. I can bring it out by the power rule of logs, and so I have natural log of E here equal to natural log of 1/2. Okay, natural log of E is just equal to 1, so that cancels out, that's just 1. And then when you have that, so this equals, follow my equals, I'm going back to the right side, So I have natural log of 1/2 is equal to negative 5,730 times k. Okay, because it's just times 1, you get the same thing. Okay, and then our next step is to get k by itself, because it says determine the value of k. So let's get this k by itself. We will divide by negative 5,730 on both sides. Right, so natural log of 1/2, that's already a constant. You don't need to worry about that too much. This cancels out. You have k by itself. You can plug it into your calculator. Natural log of 1/2 divided by negative 5,730. You'll get an approximation of 0.00012. Okay. All right. So we found k. Now let's go ahead and plug in our equation. Our equation of decay for this substance. All right, we found k, which was this number right here. Equation of decay is y equals a e. Because they don't give you an initial value, you can just keep a as it is. E to the power of negative, all right, what is it? 0.00012 times t. And then t, you're keeping, again, this is an equation of decay. So you're going to keep t as a variable, because, you know, the time in years could vary. And then this would be your final solution.